Okay, so in this video we're going to take a look at rationalizing denominators, looking at radicals when we have a fraction underneath a radical. So an example of that would be if I had the square root of 25 fourths. Okay, well, first of all, we should understand that the square root of a fraction is the same thing as having the numerator and denominator under a radical all by themselves. And if it's possible for me to reduce that, then I should. So the square root of 25 is 5, and the square root of 4 is 2. And that's pretty easy. Okay? And I could do something along those lines. For example, square root of 32 divided by the square root of 9. Okay? So that would change into the square root of 32 over the square root of 9. Okay, I know right away that that would be a 3 in the denominator. Now for the square root of 32, I'm going to have to go over to the side. I'm going to have to think about that for a second and try to break it up into what perfect square goes into 32. Well, 16 does. 16 goes into 32 twice. So that would be 4 square root of 2. So I'm going to take my numerator and write it as 4 square root of 2 over 3. Okay, so that for each of these problems, those would certainly be the appropriate final answers. It's important that we realize that this answer is rational. It is in exact form. Okay, if I take 5 divided by 2, 5 divided by 2, I get 2.5, a nice, neat decimal. Whereas if I take 4 square roots of 2, 4 square roots of 2 divided by 3, I get a really, really ugly decimal. This is irrational, and largely in part because my final answer still has a radical in it. Okay. Well, the tricky part is that we could get to something that looks like this. The square root of 4 over 5. That's the square root of 4 over the square root of 5, which is 2 over the square root of 5. And the problem is that my denominator has a radical in it. And in a final answer, we can never have a radical in our denominator. We need to do what's called rationalizing the denominator. Rationalize the denominator. So in other words, to make it rational, I want something in my denominator that doesn't have a radical. Well, if I multiply the denominator by the square root of 5, okay, then that's going to make the radical go away. But now I've adjusted the value of my fraction, unless I multiply the numerator by the same thing. Because square root of 5 over square root of 5 is just 1. So really, I'm not changing the value, I'm just changing what it looks like. That's going to give me 2 square roots of 5 over the square root of 25. The square root of 25 is 5. So there's my answer. And I can just check it real quick. I can take the square root of 4 over 5. Square root of parentheses 4 over 5. I get that 0.8944. I could also take 2 square roots of 5 divided by 5, and I get the same value. So I'm comfortable that this is correct. There's no radical in the denominator, so the denominator has been rationalized. So let's just try that process again. We do the square root of 40 over 3. So that's equal to the square root of 40 over the square root of 3. I'm going to take that a step further, and I'm going to say that's equal to, if I take square root of 40 over here, that's 4. So that's 2 radical 10 over radical 3. Now, I've got to multiply top and the bottom by radical 3. So I'll get 2 square roots of 30 all over square root of 9, which is just 2 square roots of 30 all over 3. And as my final answer, the denominator has been rationalized.